Alright, now that we got a lot of the theorems down, I guess we could take the time to solve one of the polynomial. And I also forgot to mention that the maximum number of zeros a polynomial can have is equal to its degree. So in this case, this can have a maximum of 3 zeros. Alright, so we're asked to solve x cubed minus 2x squared plus 4x minus 3 equals 0. In other words, find the zeros of this. So usually how I like to start off is Descartes' rule of signs. So for positive zeros, count how many sign variations there are in the original function. So there's one here that goes from positive to negative. There's a second one that goes from negative to positive, and a third that goes from positive to negative. So there can be 3 positive zeros or 1 positive zero. For negatives, we do f of minus x. So replace all these x's with minus x's. So that's going to be minus x cubed plus 2 times minus x squared plus 4 times a minus x minus 3. This is all going to be minus x cubed plus, oh, that's a minus sign, I'm sorry. Minus, so that's minus 2x squared minus 4x minus 3. There's no sign changes, so there are no negative zeros. And now we can go for complex zeros. There can be either 2 complex zeros if there's only one positive zero, or no complex zeros if they all turn out to be positive. Alright, so with that information, now we can go on to our rational zero test. So our p is 3 and our cube is 1. So our only possible zeros are going to be 1 and 3. By Descartes' rule of signs, there aren't any negative zeros, so we don't need to include them here. But if your teacher asks you to include all possible candidate zeros, then include the negative ones as well, so they know that you know what you're talking about. Alright, now we have our candidate zeros. Now we can just go ahead and do the tests. So how you do the test is actually take one of these zeros. I'll just start with 3. It kind of looks good to me. I'll start with 3. I just put it into the box. And then I put the coefficients into my synthetic. So that's 1, minus 2, 4, and negative 3. Then we divide. Bring down to 1. 1 times 3 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. 4 plus 3 is 7. 7 times 3 is 21. And negative 3 plus 21 is 18. So you see here we have a remainder of 18. This is too high. And there is no 0 greater than 3 by our boundedness theorem. So this is obviously way too high. So we're going to have to try again for 1. And another thing, sometimes this can be very tedious, but it's also kind of fun because you can see something to emerge. It's always good to double check your work because on many quizzes I failed to do that and I got the answer wrong. Let's try 1. 1, negative 2, 4, and negative 3. Bring down the 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1. 4 minus 1 is 3. And 3 times 1 is 3. Negative 3 plus 3 is 0. So 1 is a 0. And also by the factor theorem, x minus 1 is a factor of this polynomial. Now from here, I want to find all zeros. So we're not done. We can either go with the synthetic division once more, but since this is only 3 parts, you can go on and turn this into a quadratic. This is because this corresponds to your x squared. This corresponds to your x, and this is your c. ax squared plus bx plus c. Now, let's turn this into a quadratic. So that's going to be x squared minus x plus 3 equals 0. I don't see a quick way to factor this, so I'm just going to go ahead and go on to the quadratic formula. And it states negative b, in this case negative 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is 3. All that over 2a, which is just 2. So, I'm going to move that down. So, negative 1 turns into a 1. Plus or minus the square root, this is going to be 1 minus 12, and that's minus 11, all over 2. Now, this is where we get into complex numbers. And in case you don't know about complex numbers, I'll just remind you that the definition is I squared is equal to 1, negative 1, and I is the square root of negative 1. So we can just pull that negative 1 out. So this becomes 1 plus I times the square root of 11 over 2. And believe it or not, that's actually the answers. So your answer solution, your solution set, would be this. I always write it like this on tests. Let me finish erasing. You would say x is equal to 1 and 1 plus or minus I times the square root of 11 all over 2. And that's your answer. So you see, in about 6.5 minutes, we solved this polynomial function. You should soon be able to do this in about 3 minutes for a problem.